Welcome to Electricity and Magnetism Part 4, Electric Fields. In this part we're going to talk about how we represent electric fields. We do that using lines. And as you can see on your screen, an electric field is a space around a charge through which it can exert a force on another body. We've already talked about how like charges repel, unlike charges attract. Now you do this without touching each other. The charges interact by the fields around them. Now, how do we determine what an electric field is going to look like? Well, we use a test charge. The field around the charge is shown as lines. And those lines point in a direction a positive test charge would move, obviously when placed near that point. Now let's look at a couple of single point charges. We have a negative charge and a positive charge. And a positive test charge would obviously move towards the negative because unlike charges attract, and the positive test charge would move away from the positive because like charges repel. So we draw the lines going into a negative and away from a positive, or out of a positive, as we say. Now what happens when we have a couple of charges near each other? Well, we have a negative and a positive. You see the lines start at the positive charge and terminate at the negative. And you see they're no longer straight lines, but bowed according to the strength of the fields. When we have like charges, you see the lines come out and repel each other like this because like charges repel. Now, if these were both negative charges, obviously the arrows would be going the other way. What happens when we have some parallel plates? There's a positive plate, negative, and we see that the lines again go from the positive to the negative, and they are parallel and evenly spaced, except at the ends where you get a little bit of bow. Right now that you know we have all these different situations, you just know we have some laws or rules that we use to talk about these field lines. Number one, field lines never cross. Pretty straightforward. Inside a hollow sphere, the field is zero, which means there are no lines inside there. And lastly, for two parallel plates, the lines are parallel and everywhere and evenly spaced, which means the field is uniform. All right, hope that helped. Please feel free to leave a comment and let me know if you want anything opened up, expounded on, or more examples or something wasn't clear. Thanks.